group 1 metals with water. We're going to start with lithium. It's at the top of group 1. You can see that lithium is, like all the other group 1 metals, is stored under oil. And that's because even if it was in a container that was exposed to the air, it could react with the oxygen in the air. So I'm going to cut a little bit off. You'll notice that the surface of lithium is very dull, but when I cut into it, when it's freshly cut, it's shiny. So that's one of the properties of our group 1 metals, that they're dull on the surface, but when they're freshly cut, I'll cut another bit for you to see, then they are shiny. Now, most of them are easy to cut. Lithium's a little bit harder, but we should get there. There we go, and you can see it's nice and shiny on the surface, but it will get dull very quickly, and that's because it's reacting with the oxygen in the air. So I'll cut ourselves a small enough bit to react with the water. So a couple of safety features I want you to notice around here before we do our experiment, and you may have to quote these in your exams. So first of all, you'll see that I haven't been handling my metal directly. I've been using tongs, and I also have gloves on as well. You can see that we've got a safety screen around here, and that's to protect anybody who is observing this reaction. We've got safety glasses on as well, and we're using a very small piece of metal in a large volume of water. If you think if we were to do this in a boiling tube, the reaction, it could be so vigorous that it could smash the boiling tube. So that's another safety feature too. And you can see that I've got the bench protected with heat-proof mats as well. So I'm going to set this lithium off to the side, and let's see it reacting with water. So you can see now it's starting to react with the water. Something slightly strange you might notice is that the piece of metal is floating. With most metals, we expect them to be so dense, so heavy, that they would sink to the bottom of water, but you can see that these group 1 metals will all actually float, and that's because they have a low density. It's fizzing, it's giving off a colourless gas, that's hydrogen. It's floating on the surface, it's moving across the surface, so it's not staying still. Eventually that little piece of lithium is going to disappear, and what we will be left with is a colourless solution. And although we are doing this on such a large scale, you'll not notice much heat given off. This water doesn't feel warm because it is cold water, but actually this reaction is giving off a lot of heat. So your final observation is that heat is released. So you can write as many of those as you remember into your notes, but I'll go through them afterwards as well. So now the reaction's finished, you can see that we're left with a colourless solution. Okay, let's move on to sodium. And again, I will not handle it directly. Again, stored under oil, you can see the oil dripping off there. I'm just going to give it a quick dry. I want the excess oil off because, as you know, oil and water do not mix, and so it wouldn't react just as well with the water. Okay. So again, I want to be cutting off a small amount. That's one of my safety features, that I'm only using a small amount. Again, see how shiny that is when we freshly cut it, but it goes dull so quickly. If I cut another wee bit off, you'll see that, the shiny surface, but it dullens very quickly. So we'll put the lid on this just to be totally safe and get that out of the way, and then we'll put our small amount into water. So sodium's the next metal down in our group 1 after lithium. So let's see how its reaction compares. So you should see something different already, that our piece of sodium has melted into a shiny grey sphere. So that's slightly different than lithium. Lithium didn't do that. So it's melted into a shiny grey sphere. Again, it's fizzing. You can see it's floating on the surface. It's moving across the surface. And what you should see is that it's reacting a little bit more quickly than with the lithium. So again, it's moving across the surface. Eventually that little piece of sodium will disappear, and what we'll be left with is a colourless solution. And again, your final observation is that heat will be released in this reaction, Again, it's not that my water's getting super hot here, but that's because we've got a large amount of water and only a small piece of sodium. But this reaction produces heat. So fizzing floats on the surface, moves across the surface, metal disappears, colourless solution forms, and heat is released. And you can see our ball is getting very small now, and that's the reaction finished. So we have one more metal that we're going to look at together, and that's potassium. So let's cut the piece of potassium first of all. Again, you can see it's very dull on the surface, but when we cut it you should see that it's nice and shiny. This one we'll cut a couple of pieces off. We'll maybe do this a couple of times, but we want to make sure that this is nice and small because this is quite a reactive metal. Okay, so again, nice and shiny on the surface when we cut it, but it dullens down very quickly. So we'll cut those pieces off in case we want to see this again. But we'll put the excess back in the bottle just to be safe. Okay, so we'll get that out of the way. And let's have a look at our reaction of potassium with water. Okay, so you can see this is different again, in that we are forming the shiny grey sphere just with sodium, as with sodium. I'll just tilt this bowl a wee bit to try and get that last wee bit to react. Okay, but what you should notice is that is much more reactive. Even though this piece of metal is reacting with water, we're seeing that it actually burns with a flame. Let's see it again there. Okay, so you can see it ignites and it forms that lovely lilac flame. And towards the end you get that crackling sound as well. So again, you've got all the same observations as with lithium and sodium. So it's fizzing, it's floating on the surface, it's moving across the surface, the metal disappears, a colourless solution formed, and heat is released. But the differences here are that it burns with a lilac flame. And listen out for the crackling sounds as well. Okay, so a nice crackling sound, and there we got a nice good explosion at the end. And that is just basically your hydrogen exploding. So remember, these reactions produce hydrogen. And if you've got a flame there, we've got essentially a hydrogen pop. So that's a little bit different with potassium. You've got your lilac flame and your small explosion at the end. So girls, in this week's lesson you are looking at the reaction of some metals with water, what happens during that reaction, and then trying to decide which metals are more reactive than the others. So in this video I'm going to show you the reaction of copper with water and the reaction of magnesium with water. We're going to have a look to see do these reactions happen, and if so, how quickly. So I'm going to start with my piece of copper. You can see that it is a red brown or pink brown, sometimes it's described as. This is just a strip of copper. So I'm going to place it in the boiling tube, and we'll have a look to see if anything happens. So it might be hard for you to see from there, but I'm going to zoom in just a second. But there's no immediate obvious reaction with the copper, but as I say, we'll zoom in just a second and see what happens with that. Next thing I'm going to react is a strip of magnesium ribbon. So magnesium ribbon is a shiny grey solid. Okay, so you can see strip of magnesium here. You have maybe burnt magnesium before. We looked at that reaction last week, how it burns with a bright white light. But let's see if it reacts with water. So obviously it's very reactive with air. It burns very vigorously with that bright white light. Used it in flares for boats that are in distress and things like that. But is it very reactive with water? That's what we're going to look at now. So this is just cold water that I've used from the tap. And again, we see no obvious reaction with copper, as with copper, and with magnesium as well. If I take it out here, there's no obvious reaction. But let's take a zoom in and see what we can see with these two reactions. So I have left the copper and magnesium reacting at this side of the room for a few hours now, and let's have a look at what's happened to them. So let's have a look at the copper first of all. Does it look any different? Can you see any bubbles? No, we can't. And that's because copper is totally unreactive with water. And that's a good thing. That's why we can use it in water pipes, because if copper was reactive with water, then our pipes would wear down over time. They would react with the water over time and we'd have to replace them very often. So that's why copper can be used for water pipes, because it is totally unreactive with water. But if we look at the magnesium, it was one where we didn't see an obvious reaction right away. But now we can see there are a few small bubbles on the surface of the magnesium. So it's not bubbling vigorously. But if I lift this out carefully so that you can see it nice and closely, hopefully you can see the surface of the magnesium is covered with bubbles. Hopefully that's a wee bit clearer now. And those bubbles are bubbles of hydrogen. So the magnesium, while it's not vigorously reactive with water, it is reacting very, very slowly to produce small bubbles of hydrogen. So the way we normally describe that is that there's a few small bubbles on the surface of the magnesium. And even as I set it in there, you could see some of those coming off. It looks a bit more like it's fizzing. But if I turn it around, you can see, no, it's not fizzing really quickly, but it is producing a few small bubbles of hydrogen gas on the surface of the magnesium. So girls, over on page 7 now, we're going to have a look at the reaction of calcium with water. Calcium is an alkaline earth metal. It's just below magnesium in the periodic table, so they're both in group 2, that alkaline earth metal group. You may not have seen calcium before. So calcium is a grey solid. Now, if we have a look at the calcium we have here, it's a little bit of an older bottle. You can see that actually it looks more white than grey. And that's just because it's oxidised over time. It's reacted with the oxygen in the air. What we'll see is that calcium is quite a reactive metal. If you remember last week, we looked at it burning, and it burns with that brick red flame. And it burns quite vigorously as well. So calcium, we may not expect it to be a reactive metal, but it is fairly reactive. So what I'm going to do is I'm going to place a few of these granules into water, and we're going to see what happens. Okay, so I'll place a few granules in that now. Okay, so already you should be able to see a reaction starting. You should see that we have fizzing, and we can observe fizzing. You may not notice, but the little calcium granules are rising and sinking. We'll take a closer look in a second, but you can see already this is much more reactive than magnesium. So let's take a closer look. So if you have a look at that test tube in the middle that's reacting there, hopefully you can see the little calcium granules. They are rising up to the top and then they are sinking again. And that's quite characteristic of the reaction of calcium with water. So you can see there's fizzing, there are bubbles of gas being produced, and that's a colourless gas, and that's our gas that's being produced, hydrogen. So we know that when a metal reacts with water, we get hydrogen gas produced. So we've got fizzing, we've got our calcium granules rising and sinking. What can you see is happening to the colour of the water? If you look at the one beside it, that's unreacted water, and you can see it's colourless, it's clear, we can see right through it. But the solution now that has calcium reacting in it has become milky. So when calcium reacts with water, it forms this milky solution, and eventually the calcium will disappear after it has reacted completely. And the final observation is that this reaction actually gives out a lot of heat. That's hard for you to see in a video. But actually the walls of the test tube there will be getting very, very warm at this stage. When calcium reacts with water, it's a very vigorous reaction, and the test tube gets very warm. It gives off a lot of heat. So I'm now going to do the reaction of calcium with water again, but this time I'm going to collect the gas that I produce to test to see, is it really hydrogen? So I've got 2 boiling tubes, and we're going to perhaps do this twice. We'll see how the first one goes. About 1/3 full of water, and then I've got 2 empty boiling tubes, which I will use to collect the gas. There's other ways that we can collect gas, for example using a whole gas kit, that would then allow us to collect the gas over water, but this is just a quick way of doing it. Just all we're trying to do here is prove that the gas is hydrogen. We can also use things like a gas syringe, but at the minute we're just going to keep this nice and simple. So to my first boiling tube, I'm going to add a few granules of calcium. Again, you'll see that reaction start to happen again as we did before. So you'll see the little calcium granules rising and sinking. You'll see it fizzing, and that's our hydrogen gas being produced. Okay, and what will happen is the hydrogen will rise up and it should pass into this boiling tube. And what I'll then do is I'll stopper the boiling tube. I will light a splint and then test to see if this is hydrogen. Okay, so if I lift this out, hopefully you can see that reacting. Okay, hopefully you can see the little calcium granules rising and sinking. And I can see some of my gas pass into my boiling tube. I'll give this just a minute to react. And as I said in the previous video, that's getting very warm, and it's releasing a lot of heat. You can see lots more gas being given off now. It's fizzing away, the calcium granules are rising and sinking. So as the calcium is used up, this reaction will slow down. Okay, so I think we've probably got enough now. We'll see how we get on. So I'm going to take this off and try and stopper it as quickly as I can. Okay, so hopefully I've still got a boiling tube full of hydrogen there. So I'm going to light my match and use that to light a splint. So the test for hydrogen is that we apply a lit splint to it, and I wonder, can you remember from previous years what happens to the gas when we light it with a splint? Okay, so I'm going to take this off and apply my lit splint as quickly as I can, and hopefully you heard that squeaky pop. And that's the test for hydrogen, that when we burn it, it burns with a squeaky pop. Okay, let's see if we can do that again really quickly. And hear our nice squeaky pop again. Add a wee bit more just to get this reacting a bit quicker. And we'll put our other boiling tube over the top to collect that. Want to use a nice clean dry boiling tube, you'll see, and this was the boiling tube that I burnt my hydrogen in. I don't know whether you can see from the video, but along the inside of the walls of the test tube you can see some condensation, and that's because when we burn hydrogen it actually produces water. So hydrogen reacting with oxygen produces water. Think of the formula of water is H2O. That means it has hydrogen atoms in it and it has oxygen atoms in it. So that's a little bit damp now inside, so if we use that again, the squeaky pop might not be just as good the second time. So you can see it reacting quite vigorously there. The fizzing, the calcium is rising and sinking. The solution is turning milky white, and that is our solution of calcium hydroxide. And the gas we're producing is hydrogen. Okay. All right, we should have plenty of hydrogen at this point. And my boiling tube is really warm at this stage. Okay. So that's stoppered now. Hopefully that is full of hydrogen. Let's get a new match and a new splint.